All right, algebra. Hello. Today we are doing ratios, rates, and conversions, which is 2.6. Our objective for today is to find ratios and rates and then to convert them. All right, so we're going to convert units as well. So we're just going to go ahead. We'll jump right into it. We're going to come down to this long-winded writing that they've got here in the book. And we can pretty much ignore most of it, but we're going to look at a few things. So a ratio compares two numbers by division. All right, just an example of a ratio in case you don't remember. This is one example of a ratio. This counts as a ratio, but we're going to see mainly this kind, right? So just the division. There's also this one that I just forgot as well, that A to B. Yeah, so those are ratios. Pretty simple. I'm sure you've seen it before. So to jump into the rest then, we have a rate. All right. And a rate, I'm sure you've heard of a rate. I'm actually not going to write that one out because the definition that they have for you here is good if you feel like you need the definition of a rate. If not, it's not a big deal. I'm sure, again, you've heard the word rate before and you have an idea of what it means. One that I do want you to make sure you get written down, though, is a unit rate. Okay? And a unit rate is where the denominator is 1. All right. When we have a unit rate, you might hear things like, I don't know, like if it's a pizza, it might be like $2 per slice. Okay, so that per slice, specifically that per, and then this being singular, couldn't think of the word for a second, that tells you it's going to be a unit rate. All right, so that's kind of the main idea of a rate and a unit rate. So we'll look at problem 1 here. It's comparing unit rates. So it says you are shopping for t-shirts. Which store offers the best deal? All right, so store A has $25 for 2 shirts. Store B is $45 for 4 shirts, and store C is $30 for 3 shirts. So basically all they do is they start with this information here. That's this. All right, so $25 divided by 2 shirts to figure out how much it is for 1 shirt. All right, so that would be your unit rate, that $12.50 or 12.5 for 1 shirt. And then they do the same thing for B here, and then the same thing for C here. All right. Yeah, so basically what they're going to do is they're just doing division, right? So I'll just show you on B. I don't think we need a whole lot of examples. Actually, I'll show you on C because that one's the easiest computation. So for store C, just so you can get a good grasp of what they're doing, all they're doing is simplifying, right? So they start with $30 over 3 shirts. All right, and then they do that 30 divided by 3. And 30 divided by 3 is 10. And remember, whenever you do this division, you're left with a 10 here, and you're left with a 1 here, not a 0. So don't get that one confused. All right, so $10 for 1 shirt is store C, which you see here as well. All right, so pretty simple again. Those ones are, yeah. So store C is actually the best deal, right? That's what it asked us here, which store offers the best deal. That would be store C in this example. I want you to go ahead and do the got it problem number 1 there, and see if that does anything different. All right, so once you've done that got it example, the next really important piece is this conversion factor. All right, So conversion factor, and I'll zoom in so you can see it. But a conversion factor is a ratio of two equivalent measures in different units. And that conversion factor is always equal to 1. So an example of this they have right here, it's 1 foot over 12 inches. All right, that is equal to 1, right? Because 1 foot and 12 inches are the same thing. All right, so this is the exact same thing, right, as if you did 1 foot over 1 foot, because these two are equal. All right, so when it says conversion factor, it's talking about that. Another good example would be if there's 1 centimeter, you're converting to millimeters, or sorry, yeah, so 1 centimeter is the same as 10 millimeters. Okay, this is equal to 1 centimeter over 1 centimeter. All right, the reason for using this would be if you're converting like from centimeters to millimeters. All right, again, I'm sure you've probably done this before, conversions, but just as a refresher, that's what a conversion factor is. All right, and then it says here, there's a table on page 814 for some common equivalent units of measure. So if you want to look at those, feel free to. You're not required to, though. Just be aware that's where they are. All right, so they give you they give you a few examples here for problem 2. So we'll look at A. It says to convert 330 minutes into hours. All right, so what you're going to want to do here is you're going to do 330 minutes. All right, and then you are going to multiply that by, so you need to get rid of the minutes. All right, so let me show you. Yeah, so the way they do it is 1 hour over 60 minutes. All right, this is correct, obviously, right? So you would just do 330 times 1 over 60, which is the same thing as 330 divided by 60, and then these cancel out. You're left with hours. All right, and I don't have a calculator, but it looks like they say that is 5.5 or 5.5 hours. I want you guys to go ahead and try part C. All right, but instead of doing this, because you could just look up the answer, obviously, instead of doing 5 feet and 3 inches, I want you to do 6 feet and 10 inches. All right, so try that one out on your own. And then once you finish that one, we will move on. Go ahead and pause the video now to do that. All right, so we can also convert between systems. So specifically, we have feet to centimeters here, it looks like. Sorry, just kidding, not centimeters, meters. That would be a whole nother problem. No, we are going to do feet to meters here. All right, so it asks you to find how many meters tall the CN Tower in Canada is if it's 815 feet tall. All right, so you start out with 1815 feet. All right, from there you multiply by 1 meter over 3.28 feet. All right, and the reason for that is you need the numerator there and the denominator to cancel there. All right, so there's your that makes it the numerator. And then obviously that 1 doesn't affect anything. So then this will leave us with our unit being m. All right, and I don't know what that measurement is. All right, so it looks like it's 553 meters about. Okay, and that is not going to be exact, that's going to be approximate. So yeah, it's about 553 meters on this first example here. Okay. All right. So from there, I want you to try this example 3A. It's really similar. Really, the only difference is that it's a different number. So try that one out. All right, and then our last example, this one, we are kind of combining the two of them. Okay, so the first two problems, or the last two problems we did, we're now combining them. All right, so a student ran the 50-yard dash in 5.8 seconds. At what speed did the student run in miles per hour? Round your answer to the nearest tenth. All right, so we start with 50 yards, because that's how far he ran. And then he did it in 5.8 seconds. That's a fast kid, I feel like. All right. So we need to cancel out the yards. All right. They give us the conversion rate of 1 mile is equal to 1760 yards. All right. So 1,760 yards. All right. So what that's going to do is that's going to cancel these two out. All right. So then you can go ahead and do that conversions. You're going to have 50 because of 50 times 1 here. And then you're going to divide it by 5.8 times 1760. Which I'm not sure what it is. All right, sorry guys. I totally told you wrong there. You're not going to do it. You're not going to do that computation yet. So from here, you're going to have 3,600 seconds. All right, because that's the number of seconds in 1 hour. All right. Now from here, you can go ahead and do those computations. All right, so you're going to want to just multiply everything straight across. So you'll do 50 times 3,600. Sorry, I'm flipping back and forth. I don't know what that is. It's 180,000 on the top. All right, and then the denominator would be 10,208. So 10,208. All right, now you're going to cancel everything. That is both on top and bottom. So you'll see yards is on top and bottom there. All right, seconds is on top and bottom there. And then that should leave you with 180,000 miles in 10,208 hours. All right, obviously you're not going to want to leave it like this. You're going to want to go ahead and simplify that. All right. Again, I don't know what that is off the top of my head. If you do, you probably shouldn't be in a middle school math class. But that is 17.6 miles per hour. If you write it like this, that's fine with me. That's what we're used to. But yeah, either of those are fine. All right, so lastly, I want you to go ahead and do 4A on that got it there. And once you've done that, I know this video is a little bit longer, but once you do that, you can go ahead and meet back up with me in class. And I will see you guys there.